Combustion of alkanes. So one of the main uses of alkanes is that they can be used as fuels. And fuels provide us with energy when they are burnt in oxygen. The products that you get from these reactions, so as well as energy, you're going to get products, will depend on how much oxygen you put in. So we've got 3 types of combustion. Complete combustion. So this is in an excess of oxygen. So if there's absolutely loads of oxygen. And when that happens, we produce carbon dioxide and water. So we've got to give complete combustion of methane. So we know that methane is 1 carbon and so 4 hydrogens. We know that we're going to create CO2 and water. And we know that we're going to do that with as much oxygen as we need. So the order to balance this in is, if you remember when we learned macho, metal, anion of the acid, carbon, hydrogen, oxygen, we're going to do the end of that. We're going to do the carbons, then the hydrogens, then the oxygens. So we're going to do the CHO part. So we've got 1 carbon on the left, so we need 1 carbon on the right. We've got 4 hydrogens on the left. So if we double up the waters, we'll have 4 hydrogens on the right. And then if we look at the oxygens on the right, we've got 2 and then 2 in water, because we've got 2 waters. That's 4 altogether. We go back and make it 4 on the left. Octane, so 8 for oct, ANE, 2N plus 2. Plenty of oxygen. We can work out how much plenty is in a minute. So we're making CO2 and water. So 8 carbons, 8 carbon dioxides, 18 hydrogens, 9 waters. 16, add 9. So 8 times 2 is 16. Add 9 is 25. 25 divided by 2 is 12.5 O2s. So that's complete combustion. We then have incomplete combustion in a limited supply of oxygen. And we could get carbon monoxide, which, how will we know which one of these we're being asked to produce? This is a toxic gas. So if it talks about a toxic gas, this would probably be this equation. And we're still going to get water. We always make water. So this time I'm going to take our methane and our octane, and we're going to add oxygen and burn them, but we're going to make carbon monoxide and water. Why don't you pause the video, balance these equations yourself. So if you've managed that, you would have put 1C, 2 waters, which gives me 3 oxygens this time, so 1.5 O2s. Here we would have had 8 carbon monoxides and 9 waters, which gives me 8 add 9, 17, or 8.5 O2s. So if you compare it to complete combustion, you can see that we've gone down in the amount of oxygen we're using. We've got a limited supply. We've got further incomplete combustion, which is even more limited. So very limited supply of oxygen. You may have done this at some point in your chemistry career. Have you ever put a Bunsen on top of put a beaker on top of a Bunsen and heated it on the safety flame, the orange flame, and then noticed that the bottom of your beaker is covered in solid black carbon, soot? You still get water though. How will you know this is the equation that they want? Or how will you know whether it's this limited supply? Well, it will tell you about the products. It will either say to produce a toxic gas or it'll produce a solid product. This will be some clues. So this time again, pause the video. We're going to just make carbon and water. Pause the video and balance the equations, and then unpause and see if you got them right. So we should have had 2 waters, which is just one oxygen here. So we've gone down from 2 to 1.5 to 1. We get 8 carbons and 9 waters, which is 4.5 O2. So we went down from 12.5 to 8.5 to 4.5. So this is when there is a very limited supply of oxygen.